what's up, everybody? Welcome back. Today we are working on auto-generating C bindings to a Zig library. So the context is we've been working on this project where we have these like chambers on the screen here, right? So you see these balls bouncing around, they're hitting these like moving platforms, they're hitting this line. These are defined by a like module, we'll say, right? We're using WebAssembly modules to basically define an environment where we have some like other system who is basically feeding balls into this environment, right? And so what's kind of interesting here is that the physics for these chambers are kind of defined by the modules themselves, right? So what happens when a ball hits this platform? Well, it's going to do some sort of like we're going to take some action on the ball, right? Change its velocity, maybe change its position if it went through the thing too much. And we want like some form of consistency between these chambers, right? So we have this physics library that we're kind of working with right now that applies like default physics. So here everything's written in Zig right now, and we have like a bunch of stuff in here that's like apply collision, apply ball collision, like what is a ball, what is like a vector, what is a position, how are we representing these things. This is all like defined in some sort of Zig module. And right now like our like really base version of this thing kind of looks like this, where we have some function on our module and he takes in a bunch of balls, and for each ball he says like, hey, I like have some platform I've defined, here's like a surface, and I'm gonna like find the collision point in that ball and between the ball and the surface. I'm going to like resolve that collision and apply that resolution in some way, right? And this is nice, but one of the benefits of working with WebAssembly in this context is that we should be able to write these modules in any language, right? Part of the goal of this like chamber system is I would like to get this project to a point where people can upload code that they wrote, and we can like run the chambers as part of like a larger global simulation. We're not there yet, but that's kind of like the end goal. And so what would be nice is if people could write those chambers in any language. And like technically with the current API they can, right? Like the API surfaces here are pretty slim, but we don't want every single person to have to re-implement their own physics, especially because if they did, there's going to be like quirks about the physics in different chambers. We would like to keep some form of like consistency between them all, right? So enter the idea of a physics library, which would just be like a re-export of what we're doing right now, but in C. And so I'm looking at this and I'm like, well, how would we export a C API here, right? Say we want to keep the code written in Zig. You could do something like define physics.h, and in physics.h you would have like struct ball, right? And here you would have like, you know, his position is a struct pause, called position. We'd have like a struct velocity, or struct vec2, I guess, called velocity, and a float called radius, right? And then you could like import this in Zig, and you could write a function in like physics.zig. Say we wanted to implement like maybe adding a position of like adding a vector to a position, right? You would do something like extern function pause to add vec, and you would take in our like pause as a struct pause2 like this. Let me zoom in a little bit. And you would take in your like struct vec2 as a vec, and then you would return a new struct pause2, right? Sorry, this is supposed to be in Zig, so this is it looks like this now. Pause2 vec2. And then you would like do this implementation down here. But what kind of sucks here is you've kind of lost the like ergonomics of in Zig being able to write like pause.add v, right? Like this was really nice the way this was now with our current layout. Right, so you would say like const new pause is equal to this. And so what you would then have to do is you would write this function, and you would have to then make a wrapper struct probably in like Zig land. You would probably do something like, you know, pause 2 is maybe like a wrapper around something that's like, you know, inner, you would write C pause 2 or something, right? And then here you would write like add, and you would take in your like pause 2, and your vec, which is a vec2, which would be another wrapper around like the C API, and then you would return a new pause 2, and you would call like pause to add vec pause inner vec inner or something, right? Like something kind of gross like this, right? If this is like the way that I would do this if I was a serious programmer trying to do something in the real world, right? This is probably like the most maintainable way um to work with this, right? So then you have like your C API, you can work with it everywhere. It's all implemented in Zig still, so you get like, we would like copy paste this code basically into like this function. And the overhead after doing like the initial work here is like not too bad, right? Every time we implement a new function, we implement the C API and then add it to our wrapper. But I don't want to do that because it's not fun, right? I want to do something that I want to do because what is the point in quitting my job and coding for fun if I have to do fucking bullshit like this, right? Why don't we just do something that's way more fun and instead try to go the other way, right? We already have this const pause to definition in Zig, and we have this function add, and wouldn't it be fucking cool is if we could auto generate the other way, go from this function to this. That's what I want to play with today and see if it's possible. And I think it is, right? Zig provides this AST module. So if I go into like Zig stood const Zig, I think, yeah. And then here they have const AST. They just fucking give us the AST. So can we just like look at it and like look at the function definitions and figure out what they are? And like, surely if we see a function that looks like this, then we can figure out how to generate this from it. Right? Right? Surely. So that's the plan for today. We'll see how it goes. Yeah, and I think the plan is like maybe start simple, right? So maybe like start with just a function in the root namespace, like, something similar to this, but maybe without any custom types. See if we can like generate a binding. Once we get that, then maybe we try to upgrade to like a struct member, right? How do we parse the AST to the point where we can like find, oh, here's a struct, and here's a struct that we're trying to export, and here's a public function on it, and so we want to like wrap that, right? We kind of like go there, and then once we've got like the idea of like both generating a C binding for a normal function as well as like a struct member, then we can kind of extend that and try to actually parse out like all of this physics library. But for now, kind of the idea is like let's just start simple and see where we get. Yeah. Okay. So it is 7 minutes into the VOD. I spent a long time explaining that, but I think that it was worth the explanation. Okay, so let's make a file that's like Zig bindings test Zig. And in here, maybe we'll do something like just write some public function, and we're going to call it like add. And he's going to take in A, I32, and B, I32, and return a new I32. And he's just going to return A plus B. Right? How do we look at this? Let's maybe call this like source bindings generator or something. This is probably gonna go in tools bindings gen. That sounds right. And he's gonna have to do something. Hand wavy, we are going to have to do something with our code to achieve some unknown results. Okay, so we're gonna import the standard library. And we're probably going to, first let's just do a std debug print hello world, just so that we can like make sure that we know how to like fucking compile our code, because sometimes we forget. Sometimes we don't know what we're doing. So let's do like zig run tools bindings gen. Okay, so we get a hello world, so we're chilling. And let's look at what the like AST provides us. So we'll say const AST is equal std zig AST. And I was looking at the API a little bit before this. I think that they have this public function parse, and I think that you feed in, like we load probably a file just directly into memory. It looks like he's expecting that we can, like, that our source file isn't going to be like a gigabyte large, right? So probably we parse the whole file into source. We say, I don't know what this mode flag is. Zig or Zon. I guess we're in Zig mode. I think Zon is their like package format. So we're like, hey, we're going to parse a Zig file, and then we'll have an AST. And then I don't really know how to interact with that AST like at all right now, but we will figure it out. I think Two-Step linked a PR that will find some good examples of working with it, so I will keep this around because I don't know what the fuck I'm doing. But let's just start with AST parse. So I guess we have to like open a file. So we're going to say what? Our file comes from, I guess for now we will just hard code it because that's easier. Oh, thanks for the bits. I don't know how to say that name. Lit Marv. Marv is lit, but spelt funny. But thanks for the bits. Appreciate it. So let's say that we have like, the path is source, what do we call it? Zig binding test. And the file is going to be lit is light in German. Ah, got it. So we're going to like open, relative to the current working directory, we're going to open file path with I don't give a shit arguments. And this is probably failable in some way, I would assume. And then I think there's like a read to end alloc. Great. What does this guy take in? Just an allocator and a max size. So I'm like, I don't want you to be bigger than a fucking gig. I don't fucking care. And so then we're gonna say that the content is this, and then we have to make our allocator. So const GPA is equal to std heap general purpose allocator. And then we defer the deinitialization of this thing, and then we get the allocator out of it. Like this is just like the allocator interface, right? So this is like the actual thing that's doing the work. This is like a consistent runtime interface to that thing, and then we can pass this into this, which means that we should be able to like AST parse the content with an alloc content. And what was it? I think mode was Zig, if I remember correctly. And then I guess we just say, for now, this equals AST, and then try to build and run this just to make sure that like we're not super off base. No const GPA. It has to be very var. And then two-step got it was ahead of me there. He's like, hey, you can read with a 0 termination there if you need it, and I do need that. So thank you. Jeez, what the fuck was that? I don't know what the hell I just typed, but it wasn't good. Okay, so he takes in allocator, max byte, size hint, alignment, optional sentinel. So I go null 0. Do I care about alignment? 1, I guess, and then the sentinel. So the sentinel is just 0. Is that how this works? Nope, that's the wrong fucking command. Zig run. Okay, now he's mad that there's a bunch of leaks because I didn't actually clear out some stuff. So defer AST deinit probably, and defer a alloc free content. Pointless discard of local constant, fine. And deinit expects an argument. What does it need? An allocator. This can't be const anymore. And maybe we're chilling? We're chilling. Okay, so we have an AST. And so how the fuck do you use this thing? I think I saw somewhere like something like a way to read the root nodes or something. Pub function root decals. Right, so here they extract out of tree nodes items data. And then what do they give? They get like, look at the extra data from the left-hand side to the right-hand side. Okay. And this gives us like node indexes. What the fuck is a node? Or what is nodes? Node list is a multi-array list. What the fuck is a multi-array list? Stores a list of struct or tagged unit type. Instead of storing a single list of items, multi-array list stores a separate list for each field of the struct or list of tags and bare unions. This allows for memory savings if the struct or union has padding, but also improves cache usage. Oh, interesting. So this is just like structive array or array of structs into structive arrays, I guess. So they have like this node thing. I think. Okay, hold on. So I think if I understand what this is correctly, I'll have to double check this. We can double check this pretty easily, but just give it a sec. One sec. What file are we working in? We're working in binding gen. So I think that this is like, if I have a struct or const my struct equals struct with A is like an int, B is a float, and C F32, and C is a bool. I don't know, it doesn't fucking matter. I think that this like multi-array list is basically saying like if I had like std array list of my struct, in memory, this would kind of look like, A, B, C, A, B, C, A, B, C, right? Which is great if you're like trying to just be like, I want this struct. So then you can do like, your like array at position 2 gives you like a structure at that position. But I think that this multi-array list is doing something like they're basically like automatically converting into my structs. Say that if you wanted to do array of values, you would do like const my structs is equal to struct, where you'd have like A's is a bunch of I32s, B's is a bunch of F32s, and C's is a bunch of bools. And I think that they are just doing that conversion automatically. Sorry, like this, right? So this is like you get like your arrays for each field, and like because of Zig's compile time reflection, you can just fucking do that. So when we were seeing in the like AST that their nodes, somebody was using this with something dot data. Yeah, so here they're saying like, hey, give me all of the items for tag. I would assume that they're like auto-generating enums for each of these fields and using those as accessors, which is crazy. That's really fucking crazy. And I assume that they're doing this because they want their AST to be like memory efficient, which like makes sense. But it's just like, that's wild. This is like the first like, I feel like this is the first time I've come across something where I'm just like, holy shit, Zig, you're going crazy right now. That's very cool. Very cool. Very interesting. Okay, so we were looking at this like root decals thing. First of all, let's just prove to ourselves that we understand array lists, because I think that probably understanding the data is, I think that like overall, I've kind of found over time that like the most important thing for all of programming is like just understand what you're fucking working with, because then you'll understand like you can't build up a good idea of the interfaces around those things if you don't understand what the things are. I think, I mean, maybe you can, maybe other people can, but I can't do that very well. So let's like just make sure that we understand. If we make, I think it's similar to something you worked on in Rust. Oh yeah, when I did the you're probably talking about that time where I made a struct where I was doing like a mixed allocation at one time. I think it's like not quite the same, but very similar. Yeah, unsafe mixed uppers. Yeah, it sounds similar. But not quite. I don't think it's exactly the same. I was trying to do something where I was trying to get like with one allocation. I guess it was something like I was trying to get one allocation that provided A's, B's, and C's inline, right? So like I was trying to get like, basically the dynamic version of this, where like I want to allocate all 3 of these slices, but I want them to be like contiguous in memory. And I guess you are right that it is kind of doing the same thing because it can auto-generate what that struct should look like. Maybe. I'm not sure, because under the hood, I'm not sure if these things... Oh, interesting, yeah, so it is backed with just like one big-ass byte buffer. So it probably is doing the same thing. Where I was thinking like you could implement it as 3 dynamic allocations, but they're not doing that, which is pretty crazy. What a fun little type. Okay, so let's say that we wanted to try making one of these things. So we could just say like, my multi-array, and I assume that you have to like init this thing? No? Do I just call it like this maybe? And then my multi-array dot, how do you like work with this thing? Can I like push to it? Multi-array list. They have slices, which I assume are just like views into this thing. Contains cache start pointers for each field in the list. These pointers are not normally stored to reduce the size of the list in memory. I see. So they have like probably like bucket of bytes and then a length, and then they infer based off of the ordering of the fields where the things are. So they know that they have like baked into this type, they have the like ordering of the fields of the backing struct, and they can say, well, the first thing was a float, and I know that I have 100 of them, so the floats will be at index 0, and the thing after field A will be like 100 times 4 bytes in, is probably what they're doing here. And then they're saying, well, if you're trying to work with like multiple fields at the same time, then we like pre-calculate those pointers for you, so you don't have to calculate them every fucking time you do anything. That makes sense. How do I like... So this is like the slice interface. How do I like push a fucking field though? Dinit, toOwnSlice, slice, items, get set, append. Here we go. So I extend the list by 1 element, and here I can pass in the element that I want to extend with. I see. So if I was going to be like append with this allocator, like something that says A is equal to 0, B is equal to 1.0, and C is equal to false. And I did this twice. I'm assuming that I have to try this. I didn't actually read it. And I did this again where I said like 2, 2, and true. I assume that there's some way to like look at this data and see arrays that look like 0, 2, 1, 2, and false, true. If we understand this correctly, we should be able to see this. So we could probably do my multi-array, I think it was .slice, and we get a slice. And then we can do like slice items of .a. If we understand this correctly, I think that this will give us an array of all of our A's. So like, we did like std debug print, and we try to print this thing. I think that this will print out 0, 2. He doesn't print anything because it's fucking broken. Expected this type, found that type, so he just wants it to not be const because of course it can't be const because we're modifying him. Oh, fucking sick. Okay. I think we get it. So if I swap this like .a for like .c, then we should see false true. False true. Okay, yeah, sick. That's super cool. That's so cool. That's nice. Look, mono proc macros. Yeah, dude, doing this in Rust would suck. I mean, I think that in other languages you would just do it by hand, right? Like, I don't know if I like really believe that this is like a necessary type. It is kind of nice and cool, but like I wonder if like how bad is it really to do it yourself? But also the stream for today is essentially doing like an equivalent concept here where like there's probably some way to do this nicely where you don't need to do this bullshit, but let's embrace the bullshit because it's fun. So I guess I have no shit to talk. Okay. So we understand what these nodes are. So we should be able to say like root, what was it? Root decals? Okay, let's just like start here. This is going to give us some indices into the node list. So this is going to be like a list of nodes that are at the root of the file, probably. Can I just print the AST? If I just write like any here and write like AST and run this, this gives me, okay, that's not too interesting. Okay, let's look at, let's go back to the root decals then. So AST root decals. And we can like maybe loop over these decals. And we know that these are node indices, I think is what it said they were. Which means that we should be able to look at like AST nodes who is a slice already. And we can just try to get the thing at each index. So I guess let's start with look at how many declarations there are. Because this will give us a clue as to like what this thing is. Oops, we want decals len here. So I'm expecting to see 1, which is what we see, right? Because in our like sample thing that we're parsing, what was it? Zig bindings test. We have 1 function here. So I assume that if we did like const std is equal to import std, we would see 2. Yeah, okay, we see 2. And then if we go in here and we say like pub function, or maybe we make like a struct. Const a is equal to struct. I expect this to say 3 now, right? Because there's 3 things at the root. But I expect that if I add a function here, some function, I assume that this will not increment the count because it's like a sub thing. Cool, that makes sense. So we have like a way to like enumerate the root of the file. And so we can just say for decals, idx, can we look at what this thing is? Sorry, if I'm ignoring some questions in chat, it's because I do not strongly believe that I'm going to finish this today, and so I'm trying to avoid getting too distracted. If I start like addressing like questions like, "Oh, where did you used to work?" Then I'm not gonna finish. So I want to make sure that I make as much progress on this as I can today. So I apologize. Other days I would be more willing. Okay, so this thing is we're supposed to look at the node at this index. So can we do something like for each index, can we print, what was it? AST nodes at IDX. So this is a nodes this is a slice, so I can't index this thing directly. But I can get the thing at that index. So let's do that. So get index. So this is going to be a node. And let's look at that node, I guess. And let's just see what it does. Okay. So, oh, this is interesting. Okay, so we see that we have a variable declaration. So this is the std declaration. Here we have a function declaration and a variable declaration where this variable is a structured, like a type definition. And okay, so they have a left-hand side and a right-hand side of each declaration of each thing, I guess we'll say. And I don't know, do we think that these are like nodes in the tree? Probably. So I think I saw in the documentation somewhere, when I looked up Zig docs. Let's see. Let's go to 0.12 because that's what we're on right now. Even though 0.13 exists, it's not in the Nix repos, or it wasn't in the Nix repos when I checked a couple days ago, and so I haven't upgraded yet. But here I saw the root AST node is assumed to be index 0. Since there can be no references to the root node, this means that 0 is available to indicate null. So I think that when I look at this thing, when I see LHS0, RHS3, I think that these are probably indexes into the node list, and the LHS0 means that there's nothing on the left-hand side of this node. I don't really know what the structure of this tree is right now, but I'm kind of hoping that maybe just by walking down the node list, we'll kind of see it. So maybe what we'll do is we'll just make like a function that's like walk nodes, just to see what we can see. And I guess here we are going to maybe take in the AST, or maybe just the node list is maybe good enough. So AST dot node list slice, I think is what we're looking for. No, just node list. Fuck. AST node list slice. And we'll call this nodes. And we'll look at the current index. So this is just going to be this code here. We'll just print it, and then I guess we'll say if node dot what was it? Data has LHS is not equal to 0. We will print. I guess maybe we want to have like an indent level here. And then we will just call this again with indent +1. So we'll say like, we'll print out the left hand. We'll say, hey, we're looking at the left. And then we will call this again with the current node list, but with node data LHS and with indent +1, which means that kind of everywhere we have indent, everywhere we write, we need to say like for 0 to indent, we just like print a fucking T. And we'll do this again here. Technically, we should be doing this. Maybe we should split out a function, but yeah, maybe we'll do it. Indent print. This will be easier. I'm going to fucking forget, and so I might as well just do this now. So this is going to be a string format and some args of any type, and he's going to return void. He's going to just basically do this. But he's also going to take in an indent level. So maybe we'll put the indent first. Yeah. So this is just going to be args here, format here, and I think we're chilling. And then here we can do like indent print. I guess we just replace this with this indent print with indent here, indent, and then this is again indent print LHS this, And we do the same for the right-hand side, I guess. Okay. Let's just see what this does. It might do something fucking stupid, but... Yeah, what the fuck? Oh, it's because we're not fucking calling this function anywhere? That would do it. We say walk node, AST nodes, IDX, and indent 0, and then this will grow over time. If you look at AST node tag, it'll show something. Okay, that's useful. Node, node tag. Ah, interesting. Okay, so this will tell us what we should expect to see on LHS and RHS for each thing. That's good. Sick. So when we looked at simple var decal and we saw LHS is 0, why didn't we see that? I guess we'll see in a second. We'll see in a sec. Let's just finish this up and then we can inspect what we see. Do I forget to put an ampersand here or something? Expected 3 arguments, found 2. So on indent print here, I just kind of fucked up. On both of these, it needs to say indent. Oopsies. Here we go. Okay, sick. So here we see that we have... This is awful to read. But we have a simple variable decal where the right-hand side is a built-in call to. Okay, and then on that side, the left of that side is a string literal with no right-hand side. Okay, so this is simple var decal. Okay, let's maybe we go back to our test function here. Zig bindings test, I should say, or test file. And let's just kind of look at just the import. This will give us maybe a useful clue. Okay, so this is only that import of the standard library. So we create a simple variable. The right-hand side is a built-in call thing, and the left-hand side of that is a string literal. It'd be interesting if we could maybe like look at what those string literals are. So surely that information is somewhere. So we have like, what is it called again? Tools bindings gen. So we are only looking at like the children of the AST. We're not looking at like the value itself. So can we look at that? Like, in a node, he has main token index. So maybe this is like the name of the thing. Why is it var when the variable is const? I assume that they're the same, but maybe they're not. I will come back to that, I think, because you're right that I think that they mean like var is in variable, not var is in variable. Main token is var or const. Oh, okay. So here we're going to see that the main token says const. We're going to go down a level, and we are going to look at this built-in call to. What is that? Built-in call to. Main token is the built-in token. So here we should expect to see import, I would think. But then why is it call to? Right? Isn't... And where does the name of stood come from? I don't really understand. I feel like we've fucked up in some way, shape, or form. But we'll see as we keep going, maybe. Maybe we're wrong about what this data is. This is an index into... This is a node index. Yeah. So I don't see how we would have fucked that up. It seems like what else could it be? So if we are looking at a... Oh, we're on simple variable declaration. Main token var const var a colon LHS equals RHS. Oh, yeah, so we missed where's the name go? should there not be a name associated with this thing in some way? Do we lose that? That's not good. That is not good at all. I was really hoping that we, like, that surely that must exist. Maybe it knows it's unused, doesn't show it. Maybe. What if we write pub here? Simple var decal, main token 1. Well, let's just maybe look at the token first. Let's, like, before getting too up in arms. Bindings gen. We should be able to do something like node token. And this is going to be a string that comes from, I guess we should just take in the whole AST here. So this is AST nodes to get. AST. Down here, we also pass in AST. And then down here, we should be able to look at const token is equal to AST tokens get node dot main token, like this. And I guess we actually haven't looked at what this type is. So we need a token somewhere. And we have a tag and a location. Okay. And so the tag is interesting. I guess we'll just print out the thing right now and we'll see what we get. So we'll just write any here and just see what it looks like. So here we get a token that has a keyword const start 4. What is start there? What is start? Tokens, token list is a somewhere const token equals, here we go, stood zig token, I see. So where is this like start coming from? Token list struct dot tag is this, dot start is that. Why does this not match what I expect to see? I must have fucked up somewhere. Oh, it's token.tag and byte offset. I see. Token.tag. So where does the token go? Okay. Let's look at, somebody said this PR will maybe give me some clues on what the correct way to use this thing are. Let's maybe take a quick look at this. Holy fuck, 6,000 lines. Parse. What is this PR? It's called Zon. Do I really want to look through this? This looks complex. I think I just want to keep poking. I just want to keep poking for a second. Okay. Maybe we look at like the Zig docs here, see if this gives us any clues. So token list, clicking this will just bring us to array list, which isn't that great. But, oh, here we go. Wait. If we call some of these functions, maybe that helps us in some way. So we know that we have a, we know that it's of some type, right? We know that it's a simple var decal. So can we like look for that somewhere? Var decal, root decals, pointer type, parse, node to span, full slice, blah, 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 blah. So there is a simple var decal. Nice. Okay, so this will give us a variable declaration, which will maybe give us some interesting information here. Components of the AST, which tells us some interesting information. We get maybe, where can we get like token type node, align node, address space node, section node, init node. Which gives us a token index. So this gives us a bunch of, so this is type, align, address space, section. None of these are like its name. This, I assume, is like the initializer is like the right-hand side of the statement. The section, I don't know what this is. Address space, also don't know what this is. Alignment, I'm assuming these are like all of the things that you could row in. Like, I assume this is just like all of the things that you could have as part of your declaration. Okay, what is this? Comp time token. Thread local token. Well, maybe we call this and we look at what it gives us, and then we can maybe infer what we can do with it based off of that. That sounds like reasonable. Seems reasonable to me. So maybe we can like switch node tag, and we have you know, the ability to look at simple var decal. Everything else we just do nothing, and here we will try to maybe extract something about this thing. So we have the node. Oh, this is just at IDX. And so maybe we can do something like indent print simple var decal, and let's just like look at what it is. We will just look. Fuck! Expected type U32 found U size. Is that really not right? Simple var decal takes in a node index. Yeah, that's true. How come this works at all? Root decals gives me a bunch of node indexes. So I should just write node index here and think everything just works. I think. Okay, cool. So simple var decal is a variable declaration that has null, 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 and then a token at 1, and then a bunch of zeros and an init node at 3. So this is just the left-hand side and right-hand side that we saw. So we see the main token here matches this, and then the right-hand side is 3, init node 3. So this just matches this in the same way. How the fuck do I find its like variable name? Interesting. I guess maybe we're getting a little bit sidetracked. Maybe a little bit sidetracked. We actually don't care about imports. We actually only care about function declarations. So maybe it does make sense to maybe do a breadth first search a little bit. And so we'll kind of like put a pin in this thing, and then we'll look at this thing and see if we can extract some information that we care about from that. Okay. So we have a function declaration. Might be a cynic of me, but I've never had a good luck with bindings generators. It's easy to describe foreign language functions as you go. Yeah, I mean, I'm not convinced that I want to do it this way. But on the other hand, I think that it's a fun tool to have in the box. And I also think that global bindings generators, I think that you're right. I agree with you that like I often don't choose to use something like bindgen in Rust because I'm just like, it's not doing what I want. But if we were to write a bindings generator for a specific, very small case, then maybe we would have better luck because we can kind of focus in on the way that we want it to be for this specific case. And you're like, the complexity is like maybe manageable. Maybe not, but maybe it is. Okay, so here he starts with a keyword function. He then has the left-hand side. He has an LHS and a right-hand side. The left-hand side is the identifier. Ooh, nice. Identifier sounds good. And then he goes down further into blocks with some semicolons, and then this is probably like the shit inside. I wonder if we can maybe delete this for a second. Ugh, no, it's too not straightforward enough. We probably want to do something like filter out only the root level nodes or something. Or like, how do I say this? There's some stuff in here we just like, clearly don't give a shit about, right? Once we're getting into tag add, like we're too deep. Max depth, Yeah, that sounds like a good idea. Let's start there. Where were we in bindings gen? This might be a good reference, easier to understand. Created 1 minute ago. Look at you uploading code for me. You've done all the stuff that I want to do before I even get there. Okay, so what's going on here? You have some sort of parsing. Somewhere you must pull in the AST. Where is your like main? Parse error, context, parse leaky, probably source file name, right? So we parse the AST. We it doesn't matter. Parse inners, where probably the interesting stuff happens, where your tree is the tree. So this comes in with context, I see. And T and W are like some sort of like writers or something. Only what you'd find in the zone file. Okay, sure. That makes sense. But it's good to have something to reference at the very least. So then you look at the type info of T. I see you're trying to pull out a specific type from this zon, probably, is what I'm seeing here. And you're going over each field in T and you're trying to pull that out of the AST. Right, so you say full struct in it. You're assuming here that there's a full struct at the root if you see a struct. If you're trying to extract a struct, it must be a struct inside. And then you iterate over the fields of that thing. You've token slices, token slice. Okay, what's that do? That sounds interesting to me in some way, shape, or form. Token slice is what? Doesn't really say. But he returns probably like the string of data in there, which goes from the token start to the token end. Okay. So they pull in the ST and they look at tokens, items, start. And where do they get the end of the token from? From the location. So this is where I was getting lost before, was that we had the tokens, the token list, didn't feel like it gave me a full token, but just the token tag and the byte offset. But here they have an example of actually pulling out the internals here. So how do they do that? Token index goes into re-tokenizing. Oh, geez. That's crazy. I see. So they say, hey, there is this token at this location, and this is what I expect it to be, but I need you to actually look at the file again to figure out what it is. So probably if we call this token slice thing, we might be able to extract the name somehow. So let's go back to this simple case of trying to parse this variable declaration. We should be able to go back. Fuck, I keep typing main just out of like sheer habit. But here, let's try doing this. Our token, let's call AST token slice given this token index. That sounds way more interesting. And then we can print this as a string and just see what we get. Const. That's a good sign. Stood. Okay, wait. That's really good. Okay, so here we have const, import, and stood. We have actually lost the most interesting part to me, where we've lost like the actual variable name, but we have a lot in here. We have const, stood, equals, and then the right hand side we see import, stood. That's really cool. That's really cool. We're getting somewhere maybe a little interesting. It's possible that we are just skipping something here. So we look at the root declarations. We have a declaration that is a variable declaration at the very top. Simple var declaration. Let's get rid of this shit. I don't give a shit about this right now. And we like say, hey, what is the token associated with this thing? And it's const. And then he loses. I'm still lost, but where the like stood went. It's got everything but what I'm interested in. Okay, let's look at maybe we'll go back here. Oh fuck, dude, every time I type main. Zig bindings test. let's see if we get the function name in this version, where we look at the function add. So here we get a token function. Okay, let's actually delete everything. Just like fuck everything except the tokens. Which is, I think, just this one. And this, and this. Okay, so again, we see that we have a function, and he takes in two I32s, and then we open this brace, and then we return something that's related to like a plus b. Let's maybe print out the tag. Maybe this will help us in some way. I think std is the LHS of the const node, but I was seeing LHS as 0, but maybe I'm fucking that up in some way. Yeah, so identifier I32. Maybe the AST loses the name data? Is that possible? I thought that like Zig format was based off of the AST, so I kind of assumed that we weren't losing it. But maybe I'm wrong. I think I've also seen something about like a render function in here. But this just renders the whole tree. Ugh. Which isn't really what I want. What's in here? Render tree. So like, how do they render members? This is where it's interesting. So they go over the root declarations here, and then they have node indices. And surely this must catch everything. Well, I guess we could actually check that. So let's assume, I'm going to assume right now that if I type ast.render, it's going to print out the whole thing. Like the original file. So we can do something like stdebug or stdio stood out, write all, try ast render alloc. Or I guess we say const rendered is equal to this. And then we should say alloc free rendered later. And then we write all of this rendered shit. Fuck. Error is ignored. Yeah, so that does print out everything. So surely we have not lost the name of the function, right? We haven't figured out how to extract this like A, add, and B yet, but it's in there somewhere. So we can actually use this render as like an example of how to fucking find it. So this was in here somewhere. Render member, probably. Token tags, main tokens, blah, blah, blah. So node tags, token tags, main tokens, okay. Render token. So they look at like, so for a function declaration, okay, yeah, this is exactly, or maybe we'll look at simple var decal. Render var decal. Here we go. Render decal without fix-ups. Pub extern, here we go. So name, render identifier. So the variable declaration AST mutable token +1. Interesting. So this is kind of indicating that it's legal for us to, when we get a token, walk forwards by some amount. So this is like where is this token? So we have token is a node main token. So the node is a AST node, and his main token is a token index. And if we look at the tokens, does he tell us a length? I think somewhere we saw in a comment that that the length is not necessarily known. So how does he know where it ends? I guess maybe it's kind of like inferred from the tag what you should expect here, right? They have +1 kind of hard-coded. They have +2 kind of hard-coded. but only if, so they say like, if there's a type node, then we know it's here. Do they? Yeah, so they just have +1, +2. Interesting. Interesting. Okay, so we should be able to kind of guess here that if we go into our bindings generator, we can maybe switch on the type tag. And we should be able to do something like, in the case where it's a simple var decal, we maybe print the token. So we start by printing the main token. There's a main token for sure. Where this was maybe from token slice here. And then if we have this, we know that we can go +1. So we'll just say main token +1. And here we can do something like, we don't init print here, std debug print just like this. Yeah. And then we can just go, I guess we can print a new line here. No, we want to print a new line here. Yes. Yes, yes, yes. I think that makes sense. We will see, but I think it does. So here we see, no. Oh, it's not what I wanted. I wanted to do the std thing. So bindings test. I wanted to try the import. So let's comment this out and just look at this. I'm hoping to see the word std in there somewhere. Let's go, baby. Oh no, this is wrong. It's still here. Const std, this one. Okay. Yeah, that's not bad. Render zig, render expression might be interesting. Let's take a look at that. That's funny. It was like my thing was right over it. I think this is where I was, right? Am I crazy? I was looking at simple var decal. Fuck, where was I? I was right here. So I was coming from render var decal without fixups, which I got to from, I don't know. I got lost. Probably here. Render var decal. Render var decal. Yeah, I think I was already in there. Render expression. Yeah. I think that I was already there. But good eye. I believe you are right. Okay. Okay, so I guess if we are looking to write a bindings for this function here, add, I think that we should just be looking for a specific type somewhere, right? And now that we know how to extract all of the pieces of that type, we should be able to write something that calls the right function. Yeah, so let's just run this and see what we have. We lost a bunch of relevant information here, so let's look at bindings generator, and let's just kind of bring back the tag print. Okay. And then we want to handle whatever that root level tag is, which is a function proto multi. And we can maybe try to copy what they did in render expression for function proto multi. Where it was render tree, render expression, and we want to look for function proto multi. Here we go. So I guess probably if they're doing this, we should probably also do this. And here we can just look at what they do. So they look at the function. They create this like function proto. And then they just look at the components, sure. Function proto AST function token, return type. This looks kind of interesting. So here we'll do like AST function proto. How do they get full function proto? Okay. And they pass in the buff, which I guess for us is probably not accessible. What is buff? AST node index. The fuck? Strange. But I guess we will do what they did. And we want to look at the node, which I assume is an index here. No, this is an index. So this is IDX. Yeah, okay. And then what do? Fuck. What do they do? So they have the function token after function token. Okay. How do they like render the thing? Okay, so I think that like for us, we actually don't care about most of it. We only care about the name and the arguments. And the arguments, according to this, are, I think here we have a list of the arguments here. There's only 2, so it would be interesting to see what happens if we type 3 arguments. So maybe I'll just do this full function proto. Let's just like get this shit out of the way. And if we look at Zig bindings test, like what does it look like if we have C is also not F32? Or maybe we'll make it with F32 and then comment it out. Dev, thanks for the prime. Developer man, sorry, calling you Dev I think is disingenuous to your real name. Thanks for the prime. Caught you live, yeah, thanks. Good to hear it. Glad to have you. Okay, so here he has at the root level. I would be maybe nice to see if we're like which side of the thing of the tree we're on. So maybe let's just print if we're on left or right again. Okay, so here at the top level, they have a function declaration. They have on the left side a proto multi. So a function prototype where the left and the right are the first 2 arguments. Then on the right hand of that thing, they have some more shit. No, neither of these. This is the discard of the C parameter. This is all after the function declaration. So where are the rest of them? It must be that on the right hand side or something, there's like some sort of bullshit where we have to know like to keep walking forwards or something. Right? They're probably doing something like LHS is first arg, RHS is second arg, and then like RHS plus 1 is third arg or something. That would be my guess here. So maybe we go back into this like render and look for this function, fn proto here, render function proto. This is where we were. Do they do something? Or no, where actually what I wanted to look at was in ast.zig, I wanted to look at the definition of this. So fn proto. Fuck. Node list tag. This was the definition here of tag. No. Fuck. Where was it? Fuck. There was somewhere where they had docs of what LHS and RHS mean. Oh, this is token tag. No, it's node tag. Node tag. Node tag. Here we go. Okay. So function proto. Which one of these things are we? We're in function proto multi. So in function proto multi, I assume that these comments come from before. Yeah. So here we're looking at, so function A, B, C, D. And this is what we're seeing. We have Yeah, we're function proto-multi, and in our test function, where the fuck this thing is, this is a thing with 3 arguments. Okay, so function proto-multi is for 2 or more arguments, it seems like. Sub range list LHS. Any type and dot 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 parameters are omitted from the AST tree. That's crazy. Main token is the function keyword. External function declarations use this tag. So function A colon B C colon D RHS. Okay. I'm missing something here. LHS must be A, B, C, and D? LHS they see in I32. RHS they see in I32. This must be a range of params, I guess. But then wouldn't this one of these be a float? Right? Like, if I go into Zig bindings test again, I make the second parameter a float. And I guess let's just write like a discard all things right now. Because I don't really care about the internals. And then write unimplemented or something. You can use function proto-multi to get all the params. Whoa. Why is the first thing in F32? Okay, maybe we will follow that piece of advice. Gen bindings here. So you're kind of saying that I can look at function proto-multi and maybe see something interesting. So this takes in the tree and the node index. So this is just IDX. Does it return an optional? So this is proto. I lost. What the fuck? Why can't I jump to definition? Function proto-multi. This returns a function proto, and here I would probably look at his components, or maybe the left parenthesis is the beginning of the function arguments, I would guess. AST components is going to have params. Okay. Yes. Okay. So it was AST components. Proto AST params. And so now we can look at each param. Where we just say, we would print here, I guess, args. Yeah. And I guess this should be indent print. So we're kind of like halfway through an indent print, which is kind of annoying. So I guess I'll just kind of move this here. And we'll just say for each parameter, we're going to indent, no, we're going to walk node, AST param, yeah, indent +1. What does this give us? Oops, this debug print is mad at us because he wants this shit. Yep. Okay, so we have, let's put a new line in front of this thing too. We'll do a new line, and then we will indent print this. And then that feels a little better, maybe? Fuck! It's so hard. It's so hard. Okay, cool. So args, we have I32, F32, F32. And then looks like we kind of go deeper in again. So maybe down here, I'm supposed to new line down here as well. What have I fucked up here? Okay, but this looks promising. This at the very least looks promising. There's some like fuck ups in like the formatting here, but we do see I32, F32, F32. Okay. So here, if I were to write I32 and I32 again, we see two I32s. Okay, okay. Good sign, good sign. Good sign. So let's make sure. So let's see, double check that if we go to full function proto, we do see the same behavior again. So we said like, we have to make one of these things. This is what we had before. Var buff. This is fuck equals undefined. We pass in the buff here. Now let's just double check that this gives us like the same behavior. No thing here because I have to dot question mark the end of that thing to unwrap the optional. Yeah, okay, so that gives us the same shit. Okay. Okay. So let's say that we wanted to try to write down, let's just pretend that we're trying to call this function. No, we're gonna pretend that we're gonna try to write a C definition for this function. So that's like, let's just see if we can extract the concept of I32. Ret I32. We want params A I32 and B I32. We want to extract both of those things. We want the name is add. And I think that's it. That's all we really need out of this. So let's say that if we see a function proto multi, we want to extract this information from it. Reasonable to me. So we should be able to say, what is in this thing? Do we lose the name? Name token. Do we have a name token? Let's print out this full thing. Any proto. And then actually I want to like kind of like remove any other printing because now we kind of know that we can walk to the point where we find a function prototype and all we want is that function prototype. So here we have a name token. So we should be able to say, there's a lot of fucking bullshit printing going on here. One sec. We don't even want to do this. We literally just want to print function found, name, and we want to extract the name. So it's like proto.name token. This is going to be AST token slice of this token. And we want to print the name. Fuck. This one. I forgot a little string print. Okay, function name add. Very good sign. There's some other prints happening that I don't want, so that's like this render shit. We don't need this anymore. This is useless to us. Okay, we have a name add. Chillin'. What else did we want? We want the params. So for proto AST params, we want to do something. AST nodes at param. Let's just print this. So we print param node any, and we'll print the param node tag, which I think is valid. No, because I can't do it this way. It's AST nodes get param like this. Which are identifiers. Okay. And then we just need to look at identifier here. Both LHS and IRHS unused. Okay, so we just want to print out maybe the token slice. So we want to say like, I have some token slice from param node dot main token. And can I print that name? Oopsies. Param name maybe? Maybe? Okay, so this is the two I32s. Did we already resolve this somewhere where we wanted to get the argument names? No, we looked at the token plus one on some cases of something else. The like const, the variable declaration. We had like const std, we need to add one to get to the std. But what if I want to get to the A and B in the parameter names here? How would I do that? I guess we can look at the render function again. And we could try to look at identifier and see if somewhere they have an example of render identifier. Here we go. So token slice for render, they look at the token index. Param -2. We're just guessing? I mean, that's not a bad guess. Token slice for render, Lexme. Let's see what this is called. Render expression. So if they see an identifier, they render identifier, and they extract the token slice for render given this token index. So this token index is from the main tokens at this node. So this is what we want. So this is like that's what we're looking at right now. We're looking at the main token for this node. We're accessing it like kind of in the inverse way, but it's the same thing. Then they call. I wonder if we can just call this. Is this? No, this is not something that's exposed. Fuck. Okay. Can we find anything that looks interesting here? So the token index, we could maybe expect that there's some sort of like bullshit plus ones going on. So here they render a space, then they render the token. But where's like the name? Where is the name? Render function proto. Yeah, maybe that will give us a clue. Params list here. So parameter I see. So what are they iterating here? What are they iterating? So they say, hey, like, because it's kind of weird that they're not doing anything here for identifier. Oh, because that's like the last parameter. But if we were looking at this parameter, what do? They render expression for the parameter, which is just looking at the params. But they might need to go backwards by one to look at the identifier. What is like last param token? I see. So you can kind of just infer for each parameter that you just have to go back by one. Is kind of what it looks like there. It just kind of looked that way. Let's just kind of see what happens if we do that. So we'll say the param type is this, and the param name is this -1. And let's just see what happens if we get that. Param name, param type. And here, if we just go this, do we see, fuck, maybe -2, like that guy suggested? It does kind of feel that way, huh? It does kind of feel like that. Which is like reasonable, right? If you think about like the ordering of things in the tokenizer, it does make sense that it would be 2 back. And I think that maybe based off how we're seeing the usage in that render expression, I didn't really fully understand it, but this seems like maybe an okay guess. It does feel like an okay guess. Okay, we need the return type as well. So we have like proto AST return type. And so we just do this thing here, I guess, where we say return is, we just need the type. So we'll say return type. And then we just say const return type is equal to AST nodes get. And then we need to get the main token and then token slice that shit. The -1 must be the colon. Yeah, it did look like that when I was like, I didn't really like call that out explicitly, but when I saw this like double colon, I was pretty sure that yes, one back is the colon. I'm pretty sure. Okay, so we have a function that we found that has a name with 2 parameters and a return. So if we wanted to get crazy here, we could maybe write a binding for this, right? Am I high? I think this is all the information we need. So we could do. So, okay, let's think about this. So let's say that we wanted to write out like a zig impl file, which we'll call stdifs file, and we'll look up like the header. And let's just say that like we're writing both of these things at the same time, which means that we have to have like a header output path. So we'll say const header path is equal to impl.h or bindings.h, and the impl path is going to be binding zig. We will open files for both of those things. So header f is fuck. My poor little stupid brain can't handle it. Create file. Given header path. Any plans to autoconvert, e.g. i32 to int? I'll probably do i32 to int32, probably. But we'll see. We'll see where we get. And we have impl path. Impl f is just the impl path, and then here we can pass in header f, or was it impl f and header f? I think was the direction we did. Fuck, wrong spot. It's down here. Impl f header f. Okay. Impl header. Yep. Okay. So then when we call walk node, we call it with header or impl header. And we just say, if we find a function declaration, let's try to write out to the header. So we'll say header writer print. And we should be able to say, maybe when we pull out these parameters, for now we will actually push these into a parameters names vector. So we'll say like params stood array list of like some like struct that has like a identifier and a type. Initialize with our allocator, which we don't have one. Fuck me. Var alloc is an allocator undefined in global namespace because we're fucking hacking. We are big hacking. So we'll do it like this so that we can just use the allocator directly here. And then we should be able to say, defer params dinit, boom. And now when we go through each of these things, we will, instead of printing, we will say, this has to be variable. Could pass writers instead of files. Yeah, I know, but we did not do, there was a reason I didn't want to do that, and it was because I didn't know the type, and I didn't want to type any type. But I believe that you are right. I know that you can do like the right runtime any type version of the writer, but I just didn't want to deal with it. So we will pass the files instead for now. We will remember that for all of time we need to we maybe take shortcuts on prototype that will hopefully get cleaned up later, but they might not because sometimes we forget. But the intent is always to not leave it that shitty. STDF is file writer if you want typing. Ah, nice. That's good to know. Thank you. Thank you. So here we're going to say that the identifier is the param name and the tip is param type. And then down here, we should have enough to write out that we have like, let's see. It's going to be like return type, function name, bracket, type. For each parameter, we're going to give it the type and the identifier. So here we're just going to say this is the return type. This is the name. Then we're going to loop over every parameter that we stashed. And we are going to write maybe like the identifier or the type followed by the identifier followed by comma, which isn't technically correct because a trailing comma isn't valid in C, I don't think, but shut the fuck up. You can't stop me. We'll do this. And then at the end of this, we just have to write a closing bracket and semicolon, I think. Might as well just print the file instead of adding to the list. Well, I wanted to like have all the stuff at the end. I want to have like the printing abstract like at all in one spot, which is why I did that way. But you are kind of right. Fuck. 116. These things can't be const. Fine. Fuck. Error is ignored. Try again. Okay, so if we now cat bindings.h, we do have an i32 add, i32a, i32b, which is close to being a valid thing. So here let's do something where we'll do like a C type lookup. Files can be passed by value and don't need to be mute. Okay, good to know, but I don't think matters right now. But also good to know. Okay, so let's do this. Let's do function C type lookup, where we're gonna take in some type, and we'll return a new type. And for now, we're just gonna do it this way. We're gonna do const types is equal to type zig type. It's an enum, and we're just gonna write only i32 for now. But we're going to extend this later. We're gonna do like const enum stud meta. What is it? Stud meta enum string to enum of this input string. We're gonna say const zig type is equal to this. And this can probably fail in some way, so we'll just write like, or else return error.error. I really don't care right now. We'll switch on this zig type. I guess we need to say what type the enum is, which is zig type here. And we'll say, I guess we don't even have to do this like quotes yet. We just write i32. Maybe that's a reserved keyword actually. So we'll say, if we have i32, we return int32t. And then down here, when we're writing out our header, we can do like const param C type is equal to C type lookup given param tip. And then here we write the param C type, and we have to do the same thing for the return type over here. Yep. Yup. Return C type. And then here, let's throw a new line at this, and let's see how fucked we are. Okay. We're getting close. We're getting close. So here we have to do like some intelligent comma removal. So we'll just say, this is not how I like to do this, but I don't want to deal with it. So, you know, it is what it is, but we'll just say here, if I is not equal to params items len, we print the comma. Write all this shit. Later, I will clean that up with some sort of iterator bullshit, but for now, we just want to get moving. Fuck! -1. -1, -1, -1. There we go. Okay. So we have a function now. We have a function exported. And now what we actually, now we want to do the same thing where we want to write like an implementation of that thing. That basically exports, just like wraps the call, essentially. So we want to do something like, into the Zig implementation, we're going to write function add, export function add, A either to B, either to, either to, like this. And then inside, this is just going to call inner.add AB. Return inner.add AB. Yeah. That sounds right. That sounds right to me. So we'll say Zig impl writer print export function this open brace, which is just the name. Then we have to loop over the parameters again. We're allowed trailing commas in Zig, so we don't have to do this like bullshit check. And we can just print out a colon thing. So this is just the identifier followed by the param type, like this. And then at the end, we write out a bracket and then another type. This is the return type. And we probably want a new line here. Maybe a couple of them. Okay, so if I look at bindings Zig, fuck. Because I wrote header here. Zig, impl. Oops. Oopies. Zig run. There we go. And then we can cat bindings Zig. We forgot to write the rest of it. So we now need to write out this. Right, so we have what, the open brace, the thing, then we need to indent and write this thing. So this is new line, maybe like a tab, followed by, maybe we'll do a multi-line string here. No, it's fine. Return inner dot name. So this is just going to be name. And then we have to loop over all the parameters again and just write them in without their types. So this is like this, maybe just the identifiers. And then at the end of all that, we write a close brace, a semicolon, or close parentheses, I should say, semicolon, new line, end brace, new line again. And no parameters here. And then I think that we have like a function that calls the function. Return inner.add AB. I want some space. I missed a space somewhere here, maybe. But yeah, that's not the end of the world. It's not great, but I think that's valid Zig code. If we edit this and we just maybe like const import is equal to, or inner is equal to import source Zig fuck source Zig bindings test, like this. Like, does this compile? Binding Zig? Fuck. Zig bindings test. Let's actually make sure this is like return A plus B. So Zig build lib binding Zig. Okay, that compiles. That's really good. That's actually really, really, really good. So we should have a lib bindings dot A, where if we link against this thing from C and use the function declaration in bindings.h, we should actually be able to use this thing from C. So let's try that. Let's try that. So here we're going to say include std int. We'll fix this later. But then we should be able to say like test.c is going to include bindings.h, and he's just going to say function main. Nope, sorry. Int main void return 0. And here we're just going to call add ab to 3, and maybe we'll print fuck, how do you use this language again? int32 t x is equal to this, and then we printf x is a number, which is x. Which means we need to include std.io. But if we do like gcd-o test.c, and he doesn't like this because we need to link bindings with the current directory. Whoa. So lib bindings.a requires Zig link in some way? Okay, what if we do like Zig cc-o test.c L lib bindings dot A. How do I do this? Lib dash L bindings dash L dot. That does it. Okay. So that's a really good sign. We do see that the add is working, and if we go into like our Zig bindings test and we return this to like a multiply instead of an add because we're like fucking dumbasses, we should see 6 instead. Fuck. Oh, we couldn't build lib. Fuck. What changed? Why isn't that working? Oh, because we didn't recompile the executable. 6. Hell yes, man. Okay. So we have the ability now to, like, that's really sick, actually. So what we have here is we extracted this function declaration and we wrapped it with, what was it? Bindings.zig. So we just did this, like, super stupid wrapping of it where he basically just says, like, I have, like, a thing that has add AB and I write export function add this thing. Zig compiles this into like a library, and we've also exported bindings.h, which is like a C conversion of this thing. And chillin'. Yeah, then we can like call, we compiled this, we built some C that linked it together, and we're chillin'. It would be interesting. We need to make sure that when we build this library, the fact that like GCC couldn't link this is like a little concerning, right? Because he's like looking for Zig information. Can I Zig build lib in a way that like strips that shit out? You can omit debug symbols. Can we like Zig build lib for GCC or something? Like, yeah, this is what I want. Zig build lib does not allow linking to a C program. Does somebody tell us that there's some sort of compiler flag? Or add fcompiler RT. Let's try that. Let's try that. Oh, sick. Oh, that's so sick. Oh, F no compiler RT? I think that it wants compiler RT. I think compiler RT is like, I don't know what that is actually. What does that do? If I did no compiler RT like you said, I assume that the error comes back, but I could be wrong. Oh, GCC? Yeah, it wants the compiler runtime. So what does that do? Zig help. Zig build help. Compiler RT. No, not there. There's. I assume that this is like some sort of like. I don't know. We could. I don't have a good guess. Zig. F compiler RT. Want compiler RT. Include compiler RT. I see. So, oh, I see. So, Zig functions have some sort of like expectation on their environment that there are functions that they can call. For example, Zig probe stack. If you type F compiler RT, it basically says, hey, like when you are building this thing, please include the compiler runtime as part of your output. So that way, when I run my when I link against that thing, the function calls to the compiler the expected symbols are like embedded in there. So if I was building multiple static libraries, I would not want to do this. I would want to just link in the compiler runtime at the end or something. I think that makes sense. Prevent including compiler runtime symbols. Yeah, I see. So that's why also when they say that if you, in this thing here, they said if you build in like release mode, that goes away because like presumably you just don't need them or something. Like the symbols that you would normally call in debug mode just like disappear. Okay. Okay. So I think that kind of like indicates that this and this is done. And let's see if we can maybe pull out a struct definition. Yeah, I think that makes sense. So say we had some struct. My struct. Oh, we actually have this down here. So we'll just do this. We want to have this do something. So maybe we'll call this like print val, and maybe we'll take in a like float, and we'll say std debug print this thing. Okay. So what we want to be able to do is we want to be able to call this print val thing as a print val or something. Maybe a print val. But we want to be able to call this thing as like this from C. I think maybe we'll start with a print val because we can always fix the formatting later. And so I guess we need to just walk the fucking tree and figure out where, like, how to find this. So maybe we should also just throw in like some extra shit in here. You know, like no, yeah, like maybe we'll throw in like a declaration of a member variable here or something, just so that we like know that we have to skip something. But I imagine this will be pretty straightforward. But what do I know? I'm always wrong. So run this thing. What the fuck? I'm in the wrong folder. Panic. That's kind of fun. GDB args. No, we want to run zig build exe tools bindings gen. And then we will run GDB on that thing. Bindings gen. What is going wrong here? So this is, while we are walking the nodes, we end up going out of bounds for some reason. So this is at bindings gen's line, zig line 33. And it is just saying that there is an index 50. So what the fuck? So this is at 33 here. So a thing of walk node is just returning invalid data? It's very strange. Can we Yeah, what the fuck? Maybe we will print the index. So we'll call this like LHS with the index. And we'll do the same thing for RHS. And then maybe up here we will print out the tags again as we go. And I think somewhere down here we were debug printing something that we don't want to print, that we don't need anymore. So just kind of like nuke this shit. Right, so we actually don't want to std debug print anywhere. We want to indent print. Hold on. These need to be indent print with the indent level. And what do we see? So here we go into our variable declaration, which is our struct. Our struct has a container field. So this is going to be like the x equals something. Then we find our function declaration, which is great. And then we walk in and then we go into the block. And then this is doing like field accesses, which is kind of weird. Okay, let's go to the Zig bindings test. Let's comment out this print and just do this equals A and see if that generates the same shit. So that's fine. It's this that is not fine, which is interesting. Can we do Zig build lib source Zig bindings test? So this compiles as a library. So there's nothing wrong with the file itself. But for some reason we parse this thing, this RHS50 is a problem. Is RHS50 like a sentinel value or some way? Like, is it possible that we are at the length exactly of the node list? Like, is it like, std debug print, no, okay, maybe just like breakpoint in here. And just check something. So GDB, this thing, run, backtrace, frame 10. And can we print like AST dot nodes dot len 30? So 50 is like way out of fucking bounds. It's not even fucking close. But at some point, did we look at 30? Oh, it says length 30 right here. I just didn't read. Field access. Node tag field access. Oh, field access RHS is the identifier token index, is what you're saying in chat. Which is just not a node index. Oh, that's fucked up. I see. So we can't just like blindly walk like this. We actually have to like intentionally look at every type that we care about. Okay. That's fine. So what we would have to do is we would want to look at our simple variable declaration. Ugh. So I guess we'll say like, we'll switch on node.tag and we'll say else print indent print indent. We'll say unsupported node tag. And we'll even like write down what it is. So this will at least prevent the crash. It will also prevent anything interesting from happening. We should also new line here. And then we should just start whitelisting the ones we care about. So we know that we have simple var decal and function proto multi are the ones we know we can handle right now. And we can just start whitelisting as we go. So built-in call to string literal. You're saying only blacklist instead? Maybe. I mean, I don't really know. I don't know if those like blacklisting feels more sketchy to me, right? Whitelisting, we know that we've like looked at these things, we know they are node indices, but with blacklisting, I'm not really sure that I feel like I'll catch them all. You know? So which one was the fucked one again? I already forgot. It was field access. RHS is token index. Yeah, so like this one catch RHS as token index as well. So it's like, how am I like going through each single one and writing down that I know it's bad? I feel like it's just like we'll only notice if it crashes, but there might be other like more subtle problems. So I think I want to do a whitelist and just fucking run it. I mean, you're saying you'll notice the program crashing. I'm saying that you might not notice that it's like if the token index happens to be low enough though, then like you'll just get like weird undefined behavior. This we are going to at the very least just like not get some output that we want. And if we skip something that we don't care about, then it's fine. You know? So I'm just gonna just keep going. String literal. Container decal 2. How do you know how to do this? Do you ever search except for documentation? I mean, I don't really know what the fuck I'm doing at all. If that's helpful in any way, shape, or form. So whatever. I think that like we, just go and hope for the fucking best. You know? Function decal, function proto multi, string literal identifier, unsupported, block 2 semicolon. I don't think we need block 2 semicolon. If we look at bindings.h, we do have it. We do have our functions there, so we can kind of stop it there. Function proto simple. So was that actually enough? I think here we only supported function proto multi. Here we can also write function proto simple. And then maybe, I wonder if we'll get the binding for that second function. Return error.error. So there's no bind mapping for floats, but we can just add one of these. Error. So what is it mad about actually? Still in C type lookup. Maybe we should std debug print unsupported type this type. And let's see what it says. Error. Oh, unsupported type void. I didn't new line. So we just we can say void goes to void. All right, so theoretically, this is bugged because he doesn't know, he hasn't written down that it needs to be like part of a structure. But we did find the function, which is a good sign. So it's almost like we need to keep track of like our namespace as we go in, right? So when we find a structure, we actually need to, when we find this like container decal 2 would be my guess, or maybe our simple var decal. As we go down from simple var decal, we need to basically write that down as a parent. So here we can say that our like path is a stood array list. There's a problem here. There's a problem here where our like recursion is not tied to where we are in here. But we can fix that. But also, you don't know if the struct is passed by value or by reference. But that's okay because we will see that it'll just like end up being like a parameter to the function, I think, and I think that'll be fine. But also right now this version isn't actually using a in any way. We just need to make sure that when we call it, that we call it with a.print val, right? Otherwise, it won't compile. But the fact that there isn't like a self const a here right now, that doesn't matter. That's not a problem. And also, even if this was here, I think that we would be able to like figure out how to like parse this type out, and later, Okay. So let's try to we have to make it so that when we see a var decal, we push and pop the path. So we'll do something like here we have like maybe we have a path that's a stood array list of U8s. Mutable reference. Walk node now needs to take that thing. So we'll say stood const path var path is a stood array list of strings. Initialize with some allocator. Here we will pass in this path here. And then here we can say that we want to push to the path here. And we know that this is the name here, so we just write the name. And then if we see this at the end, so I guess we just kind of like, I don't know how I want to do this. I guess I'll just do it down here. This isn't really the right way to do it, but again, we are in prototype mode. Path.pop. Or null. Okay. Now we should be able to use this path in some way when we're writing out here. When we write like inner dot, we need to basically continually push extra fields of this path. So we'll say this stuff gets split out like this. Jesus, this is awful. But now we kind of, oh god, my brain. Eventually we need to print out the name of the function and this stuff, but in between we need to stick a bunch of dots in there. So for path component, we just write out like a dot this. So if we did this right, which we didn't because it's a fucking hard life out here, we were missing 183. If you always pass by pointer, it's fine. But if you pass by value, sometimes Zig chooses to pass by pointer because it's faster. But I think that when it does that like value or like how do I say this? When it chooses to pass by value, it's not that bad because it's like a const pointer, which I think there's like some subtle cases where that causes problems, but I think it's very rare that it matters. Did I not make a fucking array list somewhere? Am I high? Where did it go? Did I not? Dude, I feel like I'm going fucking mental. I must have just done it somewhere else. Whatever. read declaration. Okay. Yeah, whatever. Output path or something. Oh, this fucking doesn't matter. This is a bad name. I'll fix that later. Okay. He's mad about that switch statement at the end of the function. This needs to write else. I wonder if I wrote it in main somewhere. No, I don't know where I would have written that. Whatever. Okay. Memory address leaked, but otherwise we should be chilling. So if I look at bindings zig, we do see it's close. I wrote the dot on the wrong side. So this goes here. Which I'm sure everybody that is watching is like, yes, he just moved the dot. I know what's going on because I'm just kind of like ripping through it and not really understanding anything. But this looks like it works. And it looks like we should actually be able to compile this function now, I would bet. So if we do our same test where we do, we go to test.c and we call here. If we did, oh, fuck. It's okay. Bindings are broken, but if I just write include std int up here. Ah, fuck it. Okay. We have to fix this. So in our bindings gen thing, we need to, at the very beginning, like add some includes to the header output. So header f.write all, include std int.h. Right? That's probably fine. And then in their impl thing, we need to try impl f write all const inner is equal to import source zig bindings test.zig. I think it's like this. So now I think that we should be able to compile build lib from bindings.zig. This should compile. Nice. And our test.c should be able to call print val with 0.3 or something. And we should see, oopsies, gcc-o test.c and test. We had to build lib with that f compiler, with compiler RT enabled. But now if I run this, boom, baby, 0.3. And if we go back into zig bindings test, we should be able to say like from zig, here's the number. So then we build, let's like try to like staple all these commands together. Zig build lib f compiler rt and bindings zig and then before this we'd even do zig run tools oh fuck me, oh god, tools bindings gen zig and this. Z7 or 733, thanks for the prime, appreciate it. Yeah, that's super fucking sick. That's super fucking cool. I think we made pretty good progress today. We're kind of at the 2-hour mark, and I kind of want to, before getting like too deep into this thing, I really need to do some fucking cleanup. Like, this is super shit. Usually what I like to do here is I like to extract out the concept of like walking versus the printing, right? So the fact that like all of this printing stuff is inlined right here, it's kind of rough. So there's some stuff in here that's like kind of problematic in terms of I'm gonna get lost. And so I think before I go much farther down this path, I would like to maybe clean up this like walking function a little bit. But it's pretty fucking sick, I think. Like, I think that what we have here is like a really good proof of concept, right? We've walked the AST enough in order to generate bindings.h and bindings.zig for source zig bindings test, right? So we look at these things, we say, oh, there's a function in here and there's a function here. Right now we're not doing anything like intelligent, like only trying to pull out public stuff or whatever. But now you have like at the very least, like the concept is there. You can like see it in live, like it's graspable, right? This idea that the idea that we could write a Zig module where we export public functions, with no consideration for like C calling convention, no consideration for like C types. And as long as like we're only using like base level types or something, you can see that like we could get to the point where we could call these things reasonably. So I export these things through like a Zig wrapper that exports C function declarations and stuff. So pretty happy with that. I think probably I'll do some cleanup today, and depending on how interesting the rest of it is, I might do this, come back and continue on this tomorrow. I might just rip the rest tonight off stream and come back tomorrow with something else. Not really sure yet. But thanks for watching, guys. If you like what you saw, we stream most days at around 2 o'clock Pacific time for around 2 hours. Today we were working on auto-generating C bindings. We're kind of working on this global concept of this, or like long-term project of this like Rube Goldberg machine with WASM chambers that we'll be working on for a little bit longer here. If you're new here, there's a YouTube link in the Twitch description where you can check out playlists for all of our different stuff. If you're on YouTube, there should be a Twitch link in the YouTube description. There's a GitHub link in the Twitch description as well, where you can see code for most of the stuff that we work on. Yeah, I think that's it. Thanks for watching, guys. Bye, YouTube and Twitch. Let's figure who to raid.